Today we'll be solving LeetCode 632, smallest range covering elements from k-lists. First, we import the heap queue module. Next, we create a heap which holds tuples. Each tuple contains three things: the value itself, the index of the list it came from, and the index of the element inside that list. Storing the indices is important because when we pop a number from the heap, we need to know which list it came from and which element comes next in that list. We also create a variable called current maximum, initialized to -infinity. This variable keeps track of the largest value among the elements currently in the heap. The largest value is necessary because the range we form is always from the smallest value in the heap to the current maximum. Then we loop through each list. For each list, we take its first element, we push a tuple into the heap containing this first element, the list index, and the element index, which is 0. At the same time, we update the current maximum if this first element is larger than the previous current maximum. This ensures that after adding the first element from every list, current maximum correctly represents the largest number among them. After initializing the heap and current maximum, we create two variables, best left and best right, initialized to -infinity and +infinity. These will store the best range we find as we process the numbers. Next, we enter a loop that continues while the heap is not empty. Inside the loop, we pop the smallest element from the heap. This gives us the left end of our current candidate range. The pop tuple gives us three pieces of information: the value itself, the list it came from, and its position in that list. Using the current maximum as the right end, we now have a candidate range. We compare this candidate range with the best range found so far. If the new range is smaller in length, or if it is the same length but starts earlier, we update the best left and best right with the new values. After checking the range, we need to move forward in the list that provided the smallest element. We check if there is a next element in that list. If there is no next element, it means we cannot form a range covering all lists anymore, so we break out of the loop. If there is a next element, we push it into the heap as a new tuple containing the value, the list index, and the element index incremented by 1. We also update the current maximum if this new value is larger. This ensures that at all times, the heap contains exactly one number from each list, and current maximum always represents the largest number among them. The loop continues, popping the smallest element and pushing the next element from the corresponding list, until one list is exhausted. At the end, the best left and best right variables store the smallest range that covers at least one number from each list. We then return these two values as the final answer.